Okay, here is my favorite topic in NumPy, slicing. Actually, indexing or slicing in NumPy is the way you access subarrays is just the same as the way you access substrings or sublists, and you already have seen how can we use this slicing or indexing in lists and in strings. The difference here in NumPy is in list, for example, if you slice, you get, for example, let's say b equals a 1:5. If you slice that thing from NumPy, then b is not a copy. It is actually accessing the same memory view as in a. Now if you change any element in b, the corresponding element in a will change as long as a is a NumPy array. However, if a is a list or any other data structure, ordinary data structure, then the slicing, this kind of slice, gives a copy rather than a view. So that's an important difference. We need to know that rest of the indexing technique is almost the same. You do this kind of indexing, that is how you can reverse. This is start, end step, all the things are same, except how can we play with the two-dimensional arrays. Let's see some examples of indexing one by one in Jupyter Notebook and see how the slicing actually creates a view rather than a copy. So let's go to our Jupyter Notebook and see how can we play with different indices. Let's say a is np.arrange, let's say 100, and let's shuffle them. Let's stay as it is. Let's say that's a. Now a, let's say let's print some certain things. Let's say b equals a, pick all the elements starting from index 3 ending at index 9. So 10 is not included. That's b. Let's print b. Let's see what's b. So b is this array. Okay, now what I'm going to do is I'm changing the contents of b. This NumPy array is mutable. You can change the elements inside, no problem. So I'm going to change the elements, let's say one element in b. Let's say I'm going to change element number 0 in b, which is 3, and I'm just placing that element as -100, -1200. That's it. That's the case. Okay, now the contents of b has been changed. Yeah, but now let's see the contents of a. The contents of a also has changed. That's a big difference between slicing an ordinary list or an ordinary data structure or slicing a list. When you slice a list, you get another label, but that label or that variable is accessing the same memory. The memory actually is not copied. There is one memory view, and these two different names, whether you access those elements using b or you access those elements using a, the same memory is being accessed. If you change the memory using b or a, you will see the effect in both of the variables. So that's one difference. Now, after having knowledge of this difference, if we really want this behavior to not happen, one thing that we can call is we can say, okay, a, for example, a, let's say 3 to 10, and then we can call our famous function, remember that, copy. You can copy that, and now b is completely a different array. It's a different memory view. If you change b now, the effect will not be seen in a. So copy function is there whenever you need copy. One thing, if you are not going to change elements, the NumPy supplies you very fast implementation of slicing by not changing the memory view. If you are aware your algorithm is not going to change the elements, slicing will give you much efficient access to the elements or the sub blocks or sub arrays without actually making the copies inside the memory, which can take time and space both. So this is one plus of NumPy over the other data structure that we have seen so far in Python. Okay, let's play with indices. Let's say, what do you think? What is that thing? Colon, colon 2. What? Or colon, colon, let's say 5. What it will do? It will start from the very first index, which is 0. It will go to the last index, but it will pick every fifth element. So let's see. So it picks 0, then 5, then 10, then 15, because the jump is 5. Great. What do you think? What this will do? Let me just teach you by example what this will do. Yeah, what it will do. Remember, if you apply a minus here, the end and the start and end, they just get swapped, and this becomes a step from the end. So what will happen is the same kind of impact. You start from the very end, then you take the step of -1 from the end, and you just paste every element. So this is kind of reversing the array with kind of steps starting at the end. Great. So another way of reversing the array is, if you want to reverse the array as a whole, just apply -1, which means start from the end and pick every element from the end till the beginning, and the array will be reversed. This element is there, remember that? This is there. Let's change that element. So A at position, so I want to find out the index where this minus 1200 is located. So IDX is equal to A dot index. I guess there is a function index. Yes and no. Index. Oh, there is no index there. Is there np dot index? Np dot index. I want to find out the index where so index, there is no index function, indices or something. I want an index function. Is there any index function? I want to find out the index where -200 is located. There are several ways, but I want to find one. So for example, let me see whether there is an index function or not, available in NumPy or not. No, it is no longer there, but there is indices function, I guess. So indices, what that does, I guess that does the same job. Let me see. np.indices returns an array representing the indices of a grid. Okay, so I have to give a grid, and then it returns, for example, the indices of all that grid. How can I use that? Well, it becomes difficult. There may be a find function, or how can I locate the index where the -200 is located? How can I do that? Yeah, very difficult. Seems like very difficult. Oh, why don't I, rather than finding out a function, why don't I just play with NumPy? Why not? So let's say A equals -1200. That gives me a Boolean array comparing each and every element with -1200. So the array, the returning array, let me call the index array, or the Boolean array, let's say B. That array is true or false array, or 0 or 1 array. Wherever there is -1200, that index is 1, that value is 1, otherwise it is 0, completely 0. And then what I do is I just multiply that with the np.arrange with saying that a dot size. So whatever the size of A is. So because these are the indices. Okay, then what? That's the pointwise multiplication. Great. So when I will multiply them together, what I will get is what I will get after multiplication. I will get how can I find out? Actually I'm lost here literally. How can I find out the index where so that will give me what? Let's see. What is B now? The B is just an array. B is just an array, and there is this 3 that is located. So how can I find out where is this 3? How can I again, the problem is finding out the index. Okay, that's really a bad thing. Can I call this a dot indices and just give a minus 1200 and everything just worked out? No, there is an error. There is an error. Oh, I'm lost here. Literally, I'm lost here. I need to know how to find out the index where this particular element minus 1200 lies. So that's a question for you as well. I'm also lost. So let's see you in the next video. And we first will solve this problem to finding out the index of a particular element, or maybe a lot of elements. And then we will continue from there onwards to see more indexing. Okay, great. So hope to see you in the next video by first solving the problem how to find out the index of a particular element in a NumPy array, or maybe more than one elements in a NumPy array. And then we will be practicing more about these slicing examples. Okay, hope to see you in the next video.